can start to grow again. So what is mold's purpose? What's it supposed to do? It does exactly what it's been designed. It breaks down dead materials. What's inside of a home? What's inside of a building? There's a lot of dead materials. The paper on drywall, cellulose, cardboard items. Mold is bio and biodegradable. It will break it down. Without it, we'd be 3 floors deep in dead substances outside without mold. Where does it come from? It's ambient in soils and rotting vegetation and potted plants. I have done many inspections, and I have helped a lot of people find sources in their mold inspection when it was actually a plant that was giving off the mold. By removing those live plants, they actually reduced the mold counts. Mold needs 3 things. It needs to have a good temperature, a proper moisture or ambient moisture, and a food source. If you take any of those away, the pyramid will collapse. So by keeping proper temperatures inside of a building during the winter or during the summer, and controlling the relative humidity in any leaking pipes, and proper cleaning or putting proper antimicrobials down to take away the food source, you can control mold. You can actually design plans to give to your clients. The conditions for mold growth, again, is quite simple. They really like mold growth or relative humidity for mold growth over 60%. And as I had stated earlier, the EPA does recommend 30 to 50%. ASHRAE, they actually recommends 4 temperatures in the winter and in the summer. In the winter time, our temperatures indoors shouldn't exceed 75 degrees or go below 68. And in the summer, between 73 and 79. If you get it too hot in the wintertime and it's cold temperatures, the walls will start to sweat or condensate or achieve dew point. And that will start to create food and nutrients for mold to grow on. Dr. Kolowski of Penn State University designed this slide many years ago for us. This gives you a generic psychometric chart that shows how mold and when it'll start to grow. As you can see, it'll start to grow really significant at 60% and higher. Mold will grow on just about anything. It'll mainly grow, especially like penicillium or aspergillus, will grow in cellulose materials. Wood, paper, it'll grow on block walls. It'll grow on the biofilm that's on the block. One of the biggest things in the teachings that we do is we start a little conversation about, does mold grow on glass? And that raises questions of people saying, yes, it does. No, it doesn't. It doesn't actually grow in the glass. It grows on the biofilm or dirt and debris, the food source on the glass or plastics or metal. It'll grow on biological sources, pollens that are in there. Mold will grow on itself. It'll grow in bacteria and viruses. It'll grow on the byproducts of everything. Pet dander, human skin. It'll, as dust mites die, mold will grow on that to break them down. Humidifiers and dehumidifiers are a source not only for other indoor air quality contaminants, but for mold. If you're familiar with humidifier fever, that's from stagnant water that's either in a humidifier or in a dehumidifier. Mold's been a problem for a very long time. but it really started to become more of a problem in the 70s when the construction changed due to the oil crisis. Foreclosures. We know as inspectors, these homes have been closed, some of them, for a very, very long time. No heat, pipes have broke, moisture is everywhere, and mold's starting to grow in them. The lack of building maintenance in some of these buildings that's been abandoned. It's been real popular with the sicknesses, building-related illness or sick building syndrome, and the lawsuits that went along with it. And the big thing is the environments. Depends on where you live. Florida has more mold than Texas or in the northern states. Floods. If you're with where Hurricane Sandy has happened, we have sent many assessors in to do inspections on Hurricane Sandy. We've also had the problems with Rita and Katrina back then. It's getting more prevalent. According to the Bureau of the Census, exactly 35% of homes are damaged due to a water or moisture event. Could have come through the walls, could have been just pipe leakage. What ASHRAE is actually looking at is improperly vented fans and appliances, not allowing the heats or the food sources to get out, and where the exact fans are located to their discharge. I know as an inspector you've probably never seen a bathroom exhaust fan that just vents into the attic, or a dryer exhaust that goes into that wonderful little pan of water and it catches all the lint and then the mold that grows in that water. This look familiar? Housekeeping issues. If it's not kept clean, this is what can happen. Venting issues, just like I had said. There is proper calculations for venting, especially in attics. Not just the exhaust vents that discharge into the attic, but the cross ventilation that's required in an attic. HUD recommends that you do a length and width and then divide it by 200, and that calculates the amount of square footage of actual cross ventilation should be done. As you see from a standard build of a house, as new construction is done and performed, and for those that do pre-inspections as houses are being done, they leave the particle board out to the weather elements. It gets rained on. Then they wrap Tyvek around it and seal the mold in. You have to watch for those as well. So how does mold exposure occur? It is very, very easy. It's naturally occurring. Mold will grow and release spores that are very small, very light, and travel through the air. Then we're exposed in workplace air that has possible mold, or outdoor air that's being brought in that has mold with it as well. You get exposure through just general breathing. Interior and exterior doors opening and closing. We define what a red flag is in the industry. When an inspector goes in or somebody goes in as an environmental consultant, they'll say, we have a red flag issue, or we see some red flags that's caught our attention. And those are defined simply as visible mold, evidence of water penetration, could be a stain, cracked in blocks or foundation walls, poorly maintained HVAC systems, heating, ventilation, and air conditioning. You pull out the filter and there's a big hole through the filter, and you look in the return and you see a lot of mold, well then it's circulated through the home. And again, you've seen the pictures of the improperly vented fans and appliances. Here's just some general pictures of red flags. Here's a carpet. As you see, looks like rust. That's actually mold. There was a leaking pipe in the wall that went to the basement. Shower. You can see around the edges. Could have this been from the interior coming out? Could it be from pipe? Could it be just from general when they step out and water hits it? But it's classified as a red flag. This is inside of an HVAC system. This was one that was done by one of our members. And as they took pictures of it, you can see this was actually a mold of penicillium in very high concentrations. And it was set through the whole entire building. Simple water stain on the ceiling tile. At this point, this is an active moisture stain. Could there be mold above it? Could there be mold behind the wallpaper that's curled and the wood trim? There could be, but also I must inform you about protecting yourself. If you take on the liability to pick up that tile and look behind it, make sure that you have an intrusive agreement signed with your client in case that tile becomes damaged. Wet tiles are very, very, very brittle. So mold and fungi are actually divided into categories, and we'll be talking about this with some of the generalizations of lab reports. There's allergenic. Most of the molds are that which you'll be testing for. And about 10% of the population, or 1 in 6 people, have some type of an allergy to mold. Wheezing, coughing, watery eyes. Pathogenic molds are your typically infectious molds. I give you mold definitions here, or mold types: dermatophytes and Scopolarypus. Dermatophytes are your molds that would be ringworm, fungal nail, athlete's foot. Those are all fungal infections, and you'll find that they're pathogenic molds. Then we have toxigenic. And a toxigenic mold is the ones that we need to be a little bit more concerned about. They produce a mycotoxin. And what that mycotoxin is to do is to break down the immunity in its host. For instance, if you was to take penicillin because you're sick, the penicillin will go find the virus and break it down so that your immune system can then get rid of it. That's why some people are allergic to penicillin, and if you have penicillium molds that are out there, you could have a concern as well. We have aspergillus. Aspergillus spores can be very, very nasty. Stachybotrys, or the media-hyped black mold, and then Alternaria, which is the sister to Stachybotrys. People say that, molds do not have any effect on humans, or there's nothing been confirmed. The American Industrial Hygiene Association in '96 had issued statements on molds requiring risk management, and you can see the names. These are specific molds that they even said was a problem to human. And also, if you are on Twitter, I would suggest that you subscribe to the Aspergillus website on Twitter. They'll give you a lot of information that is confirmed on fungal lung. Again, mycotoxins, very simple. It breaks down anything so that it can digest it. The health effects that are associated with mold exposures are so much in variance. That's why there are no threshold limit values. Molds can affect people so differently, but it could be the amount that is in there. It could be the type that's there that affects that certain person. That's why we do testing and we do controls to verify where we are with the indoor relationship of mold compared to the outdoor relationships. What the industry defines as a healthy home scenario for mold is if the indoor samples are quantitatively equal to or less than an outdoor sample or a control sample, and if they're qualitatively similar. And this comes out of the American Conference of Governmental Industrial Hygienists. A brief guide to mold and moisture from the EPA states no indoor growth of mold is acceptable. There are investigative protocols. In our courses, we teach many different types of industry-recognized and adopted protocols, one of which is being with the American Industrial Hygiene Association and IICRC S520s. In any type of training that you go for, you need to have some type of protocol that requires a systematic approach and have an objective. You're going to gather information. You're going to do client interviews. You got to locate the cause, determine whether there could be a potential problem, and get it remediated and isolate the source. The investigative plans that you might come up with are going to be questionnaires for the complaints that are going on. And keep a diary as you're going through your walkthrough. You'll design sampling procedures. You may want to take on the responsibilities of doing a remediation protocol. And always, in all of the work we've done in all of the hurricanes, a post-remediation verification. That means that the remediation was successful. So in general, you need to interview the client and say, is there a problem? What is the problem? Go there, look and see what the problems are, possibly take samples, give it to a remediation company, and then that remediation company should contact you to do a follow-up testing after they have done it, after they've done the remediation. When you do your inspection, you want to get the symptoms, history of any water damage, walkthroughs, and look for visual colonies of mold, and is there proper ventilation. We teach all of this through the courses. When you conduct the initial walkthrough, and this could be commercial, you'll want to get a maintenance history on what's going on. Any sampling that you're going to do, you're going to notate. You're going to take photographs and or videos. For those that do high-end inspections or do energy audits, you may already have a thermal imaging camera of Fluke or FLIR. You can use that to identify where the moisture is coming in. But please be advised, thermal imaging does not detect mold. It detects thermal temperatures. If there is a moisture event, it would be colder and blue. Thus, if you have colder temperatures, there is the potential for mold to be there. There is invasive inspection techniques. You could use a borescope, look through a receptacle cover in behind the wall. In certain areas, you may lift a ceiling tile and use that. The new types of borescopes have come a long way, and those borescopes have video capabilities and picture capabilities. As you see, this is actually a BR200. You can take that screen off, set it aside of you while you're using the scope, and video your inspection. This is an idea of what happens. Can mold grow behind the walls and never show through on the actual side that you're looking at? Yes. It can grow between the walls in immense proportions. It can grow behind wallpaper. This is why moisture meters around windows or doing thermal imaging is so important. And again, behind wallpaper, it never showed through the other side of the vinyl. But yet when it curled and they pulled it back, there it is. As you see, those are real floor tiles. Do you think mold's under there? This was an inspection in a hotel, 25-floor hotel that had mold counts beyond belief. They tested the exterior walls, and all the walls came up very high for moisture, and I told them to pull off the wallpaper, and when they did, as you see below, there was mold behind it. We call this the now you don't see it, now you do. In our industry, the EPA and other environmental consultants and home inspectors know the words of sick building syndrome or building-related illness. There is actually a case-defined scenarios for each one. If you use sick building syndrome, it's about you have symptoms that do not fit some type of a case scenario. And building-related illness would fit a case-definable disease, such as legionellosis or Legionnaire's disease. When you do monitoring and testing for mold, it's very simple. You take samples or whatever testing method that you're going to use, swabs or aerosols, we're going to cover that. You need to choose one of those and have a logistical connection to the observation and the complaints. It is not just simply, I'm going to go in and take a mold test for no reason at all. There needs to be. It could be a real estate transfer. And in those we'll discuss, there is a accepted method called a mold screen that's done in a real estate transfer because your client wants to know, well, is there mold present or not? That is a reason to do it, and we'll cover that in a couple slides. There are air and direct samples. As you can see on the slide, there's many types of air samples. It could be a culturable or a viable, or a non-viable or a non-culturable. Either one of those methods for air sampling, you have to have a pump. Direct samples, numerous. Swabs, tapes, carpet checks, wall checks, bulk sampling. But those require direct examination by the lab. And those will only produce low, medium, high, moderate, heavy, many. Those will only say that type of result, where an air sample will give you numbers. There are X amount per cubic meter of airspace. Break down real quick on what this is. Viable or culture-based. Viable, you are sampling a living organism, and you are sampling it to see whether or not it is still alive. Those are reported in much different definitions, and I strongly urge that only a person who is very knowledgeable in mold assessment and sampling techniques do viables. In a simple base or your preliminaries, you do non-viable. This uses a spore trap. Very simple. You set it up for a certain amount of time, certain amount of liters, and then the lab will report it to you in whatever the particles are per meter cubed of airspace. There's a long calculation they do, but they'll report it to you. What I always suggest as a start for those who already are doing or thinking about getting into viable, you do a non-viable test first to find out what is there in the air, to then derive you of what you're going to do for viables. Viable air samples, you can actually detect fungi and bacteria. Again, there is a lot of concern. There is a lot of specific medias you have to use, and the labs will guide you through that. General idea of what a picture looks like of impactors for viables. Those sample the air and draw through holes in the plates. There are about 200 little holes in there that impact it into an agar solution. This is a typical setup. These are the type of agar plates you got to do. It requires media. We won't go into absolute definitions of all these, but in general, you'll use either a PDA or an MEA agar solutions. Non-viable, the most popular. This is what most everybody seems to do. They're done in spore traps. It'll give you the quantitation and identification of what's there. They can be used in an indoor and outdoor comparison to come up with a hypothesis of you have a mold present indoors that's not outside. Further investigation is required to find out where it's coming from. The sampling cassettes, they all collect airborne spores. A lot of the labs, they'll give pollen counts and fibers and other particulates. They'll tell you to use the device appropriately to the liters per minute. That's recommended by the manufacturer. And any of the mold spores identified to a genera level. These are the common spore traps that are out there. Aerosols, real quickly, 10 minutes of sampling time at 15 liters. Allergenco, 5 minutes at 15 liters. Micro 5s or Z5s, 5 minutes at 5 liters of air. Mold snaps, 5 minutes, 10 liters of air, or 15 liters of air. As you see, it will flow in the top. The spores will stick fast to the slide, and then any of the other air goes to the sampling pump. When it gets to the lab, they'll cut this open and analyze the slide and then tell you what you have. This is a simple setup for non-viable. Respiratory height, 3 to 6 feet. Timer, pump. Very simple. Direct samples, we can go on all day about this, of what's out there. There are many. But all of them are identified as qualitative and tell you low, moderate, or many. And you sample the red flags you've visually seen. Sterile swabs, you swab the stain, send it to the lab, give it appropriate numbers. You know, in general, you pack it up and send it to the lab. Tape lifts are very simple. You press it over top of the mold or stain, and it has a predefined sticky substance. The advantage of these tape lifts are they don't cause damage. Regular tape will cause damage, so I strongly urge you to get to predefined tape lifts. Carpet cassettes, you can sample the carpet using your same pump. This might be if you want to get a historical identification of could there be mold in the carpet. And then sampling in the wall or in an HVAC system. That's a wall check sample. You'll actually drill a hole or go through an area like a receptacle cover or a light switch cover or any orifice that you can get in behind the wall and sample it. And it will find the types of mold that's behind the wall. Bulk sampling anymore today is downplayed by the laboratories. If you're going to take bulks, only take very, very, very small pieces, 1 inch by 1 inch to send to them. New testing methods that are out there, the EPA has one called the ERMI, which is the Environmental Relative Moldiness Index. It's very expensive to do. Lab fees usually run about $150 to $200, but it's a dust collection. Simply using a common household vacuum cleaner or a small HEPA vac if you have one, and sampling the dust. What it will do when you send it to the lab, they're going to compare it to what the EPA has identified as being type 1 or type 2 species of concern. Did you hear what I said? The EPA says these are molds of possible concern. And these are that's group 2. It gives you a value, and then it'll give you a score, which is an ERMI interpretation, and then it gets compared to the moldiness index chart for your area. When you are in the highest, you have a problem, and it's very simple. Red, yellow, green. Green, no problem. Yellow, caution. Red, we have a serious issue, and it needs to be identified a little bit more in depth. We also have other testing devices that will test for specific molds, Penicillium, Aspergillus, and Stachybotrys. We use the general term This is the pregnancy test for mold. One line means that it's working, 2 lines mean we have a problem. We also use ATP, endosine triphosphate. That's the matter that makes up all living things. The only problem with using ATP is it does not tell you what type of mold is there. It could be bacteria. It could be virus. It will just say to you, we have a concern because it is over 100 and there is something living on that surface that should not be there. We also talk about QA/QC practices, about taking and making sure your equipment is calibrated. We are going to have an offering. We are going to be doing calibrations of pumps here within the next 30 days. Now, we talked about typical real estate transactions. If you have red flags present, you're an inspector, and you're doing a real estate transaction, you take a direct sample of a red flag and an air sample in that area, and then a control. If the clients do not know what they want, or there's no visible flags, they just want to say, we just want to know, is there a potential concern? It's called a mold screen. You take 2 inside samples in the common areas and 1 control outdoors. It's that simple. Then we'll get lab reports. Once you pack everything up and you learn how to mark down your sampling medias to send to the lab, which we'll teach you, you're going to send it to the lab. The lab is going to give you a report that's going to tell you how much mold was there, what kind it was, what type, and some of the labs will actually do interpretation and say that there is an unusual condition. When we interpret lab reports, there's a lot of people who say, you know, we just don't know how to do it. One person says one thing, one person says the other. Whatever lab you're using, ask them. Ask them for the definitions of what they're doing. Some labs have taken on themselves to put in their own threshold limit values and have a cutoff, where other labs use indoor-outdoor comparisons or control comparisons per the American Conference of Governmental Industrial Hygienists 19.5.3.1. Example lab report. Very simple. As you can see, there's an outside and there's an office. You can see there are molds that are indoors that are not outdoors. You can see there are molds higher outdoors than indoors. At the end of this, you will determine whether or not we have a control issue, and when you see that the total counts are 8,000 compared inside compared to 1,300 outside, there may be a little bit cause of investigation. This is an example of a direct sample. As you will see, it says moderate penicillium, moderate condospores, occasional. This is what your direct samples will produce in the lab reports. Here's another type of a lab report where the lab will actually do interpretations. They'll say what it is and what it isn't. Now, the prior labs, you know, you can contact myself. I'll tell you who all the labs are and where they are, or you can go to ESA's website and look at the list of labs to choose from. Here's another type, very colorful, and gives you a mold score. This is direct samples. As you see, there's no growth found, then there's low to start to be moderate. All summaries in a lab report will have some type of idea of, here's your interpretation of what that mold is. It'll say penicillium known to grow on. The report summary section of a lab report is very, very important. This helps you identify, well, you know, I was sampling a cellulose material and we found penicillium. Well, now you know where it was. Now you have a source. Now you have value to your client to say, I actually know where the source is coming from. So what are your typical charges? There's a national average. It's been through all the years that we've been doing mold sampling, and it's always come up to somewhere between $125 to $150 per sample. But the new ways that are out there is they charge a consultation charge of $125 to $250. That's just to go out there on site. And then they'll apply, okay, I have to take one sample for a direct, and they'll apply that with the consultation charge or include it. Or you can charge $75 to $95 additional for each sample thereafter. What's your hard costs? Your hard costs, yeah, swab, $1. Air sampling device, $4 to $5. Lab fees, depending on who you use, can be as low as $15 to $37. And then figure your shipping costs. Some labs will pay shipping. Some labs do not. You have to discuss this with the lab of your choice. But as you see, the fees are minimum compared to the $125. On average, 3 samples are always taken on a job site. So at those 3 samples, and you have $375, and you have a hard cost of, let's say, $75 or $100, you're making a potential of $275 to $300. Now I'd like to go in a little bit about remediation and abatement. We talked about what your sampling can be and your charges for that, but you may want to add another service. It's called a mold remediation protocol, and that is the plan for the remediators. We do have those courses as well. But in any event, after mold's been found, something has to be done, and remediation is going to be done one way or another. The key to it is control the moisture. They must take and address the source of the problem and address any high humidities. A good remediation and abatement is going to protect the health and safety of the occupants. They may want to consult with a health professional before it's done, depending on your client or depending on what they're allergic to. And we also discuss about personal protective equipment. You as an inspector, if you're going to do an inspector, you need to carry PPE or personal protective equipment. Simple glove, half mask respirator, and some goggles or a dust shield for your eyes. Mold can affect you as well. The main purpose of remediation is to clean up the mold. It's got to be clean and return it to the nature that it should have been originally, which was clean and mold-free. All the mold contamination must be taken out. You need to understand, dead mold is just as bad as live. And I'm going to discuss this here in a couple slides from what IICRC S520, Mold Guide to Mold Remediation and Abatement, is. And this is where we come into it. People have gotten into the habit of using biocides and antimicrobials. Sometimes the biocides are often toxic to us. Some biocides are considered as pesticides, and in some states you've got to be licensed, especially like areas like New York. Biocides are good to be used during remediation. There are alternatives. There are detergents that are recognized as a cleaning product to do mold remediations. The antimicrobials and biocides, you know, some are not interchangeable. You'll hear, well, I used bleach. Bleach is only a disinfectant, and it's only going to be applicable for about 48 hours. Then it would have to be cleaned again. Sanitizers, same thing, like Lysol. But biocides incorporates disinfectants and sanitizers in there and has a longevity kill. Could be up to 90 days or longer. You have to read the biocide that you're using. And again, you have to be careful. Antimicrobials can be classified as pesticides and they may be regulated. But in any event, it's to treat the source for future contamination as well. We also talk about project monitoring. Project monitoring, that is you. If the remediator's in there, you need to work with them. Go in, look at, hey, you need to make sure you're doing this, because when I come back to do the post-remediation, I want you to pass and gather the information. You have to figure out the monitoring points and formulate, how they should take and do this during the abatements and what to do after the completion. Sometimes these will go to court. I can't not promise you you'll never go to court, but as long as you're doing everything that we teach you in the classes, you will be covered in what you need to say in a court of law. In an abatement project, the AIHA, the American Industrial Hygiene Association, even states that the Quality Assurance Performance Indicator documentation that the precipitating water or moisture sources have been identified and eliminated. ACGIH, IICRC, they all state you must get the moisture issue under control before you do the remediation. There's new remediation technology out there. We call it fogging out antimicrobials. We call it ozone. We call it heat treatments. Non-intrusive remediation because of the cost and how you can take and apply it so effectively. That's remediation. No, it's not. Antimicrobials are not an alternate to remediation. It's used in conjunction. Remediation means the physical removal of that mold contamination. IICRC S520 5.8.1 will specifically state that. And antimicrobials that are used to kill mold and you do not remove it, it does not kill their allergenic or toxigenic properties. And again, quote out of IICRC S520 5.8.3. A good remediation scenario is do the initial assessment, correct the moisture source, have a protocol developed, remediation done where it's removed, final visual inspection by you, and a post-remediation sampling and verification at the end of the job. A to Z. In a court of law, that stands significantly. Typical remedial setup. It's enclosed. There's an actual zipper door covered by another plastic, and remediation is commenced on the other side with air machines running. In a larger scale, where it was flooded, the flooded materials were removed, everything was cleaned up, still a little bit of dust there, but as you see the plastic behind, everything's been cleaned. This is an air scrubber that's run while remediations are done, or if there is just mold that's in the air, not present anywhere, this is called air decontamination. Is there rules and laws? Yeah, then there's guidance. We talk about the EPA, New York Department of Health. We call it the mold remediation guidelines, and they're going to be revamped this year as well. American Industrial Hygiene Association. They have a couple different field guides, and all these are able to be gotten. Advanced industry guidance, IICRC S520, ACGIH, bioaerosols. If you're an inspector, these two books you have to have. And there's laws. Virginia put one in, and unfortunately, they repealed it. This year, they took it out. Will it come back? We're in negotiations and talking to them and trying to get it back in play. Florida, they do have laws. You must take an approved 16-hour course. You must take a state-recognized exam from ACAC, the American Conference of Accredited Certification, and they are very strict on who can and can't. If you are just getting into this and you have no degrees in science, you'll have to be 4 years under supervision of somebody who is certified. Arkansas is one of the toughest that's out there. Basically, you've got to be a PhD or a certified industrial hygienist to do sampling and be certified by ACAC. Texas, they have a 24-hour course, the TMARR. And then you have to take the state-administered exam that we helped create with Dr. Quaid Stahl. Louisiana, board approved, 24 hours training. Connecticut, they don't have actual licensing, they just have a reference that you should be doing. Maryland, be advised, Maryland's law goes into effect this year. It's effective July 1, and you must take an approved course and take the general ACAC exam to be certified. New York, they have a bill on the table. They're looking at trying to pass one. It's for public housing. New Jersey has 2. They want to establish indoor standards. New Jersey wants to actually take on the industry and set threshold limit values in their state for mold. Then they also have one for the Mold Safe Housing Act. Landlord will have 72 hours to perform an investigation, and he dare not do it. Kentucky, this almost went into effect last year, but it's coming in, and they're going to recognize IICRC S520. That is an ANSI certified document. Who's liable? Well, it's going to start out with an attorney. It's going to go down through the whole process. They'll drag a realtor in. They'll drag the inspection company in. They could drag an appraisal firm in, and the actual homeowner if they had falsified anything on their disclosures. But I can assure you, if you have all of your ducks in a row, you will be able to beat any of the liability that's there. I have several members who take and go to court. They actually advertise that they will back up people who do proper mold inspections, and they have won. The litigation comes basically when an inspector just blatantly did not report visible mold or suspect mold or water entry. We had one member, I tried and tried to get him to label on there about mold. He said, I work with the realtors. I don't want to lose my business because if I don't work with them, they're not going to give me work. I kept begging and pleading with him. Please don't do this. I'm telling you, you're going to get in trouble. He made the paper. Him and the realtor were sued for the value of the house, and they posted the picture of the visible mold in there, and he said there was no problem, no visible mold. The realtor paid $150,000, and he paid $150,000. He did not have insurance, and they took his house. You see it, you call it. What do you have to do to get your mold business going? Complete a good training. We are going to offer a very special discount for this online webinar and complete a good 16-hour training minimum, not an 8-hour or a 4-hour training. You need to have 16 or 24 hours of training in mold assessment. Then you need to get the equipment. Complete the training, get the equipment. Then identify your target market. We cover that in your training. We tell you how to go market them. We give you a 4-week kind of business plan to do for your marketing. And then prepare a marketing plan, how you would do it, and we cover that as well.